In this video lesson, we'll be investigating how to graph quadratic functions. We will be focusing on graphing the standard form of the equation of a parabola. For our first example, we will be graphing the equation f of x equals negative x squared plus 5. When graphing any function, we should always consider what is the domain, range, the y-intercept, and the x-intercepts. The domain of any quadratic equation will always be all real numbers. Take a note of this slide and remember that to calculate the y-intercept of any function, you plug 0 for your function. In this case, in the standard form for the equation of a parabola, the y-intercept is always the last number, c. Thus, in our example, the y-intercept is 5. To find the x-intercepts of any function, set the function equal to 0 and then solve the resulting equation for x. For example, we solve our equation, negative x squared plus 5 equals 0, and find that our roots are positive or negative square root of 5. Remember that to calculate the range, we need to know two things: the vertex and the orientation of the parabola. Our parabola opens down because the leading coefficient is negative. The vertex, labeled hk, still has yet to be determined. But since we already know the y-intercept and the x-intercepts, we can begin by plotting these 3 points. We can find the x value of the vertex by taking the average of the two x-intercepts, which in this case is 0. By plugging 0 back into our function, we can actually calculate the y value of the vertex. Thus, we know that the vertex is 0, 5, and that the range is all real numbers less than or equal to 5. Finally, we can graph our function by smoothly connecting all 3 of our points with an upside-down u. Let's take a look at another example of an equation in the standard form. As before, we begin with the preliminary setup. Here I have already indicated that the domain is all real numbers, the orientation is up because the leading coefficient was positive, and the y-intercept is 31 because in the standard form we simply take the final number. We have yet to determine the vertex, range, or the x-intercepts. To find the x-intercepts, we set the equation equal to 0 and solve. In this example, we will solve by using the quadratic formula. Using the quadratic formula, we write x is equal to 12 plus or minus the square root of 144 minus 4 times 1 times 31, all over 2. We will need to take a few steps to simplify this expression. Feel free to pause the video and follow each of the steps below. Note how we simplify the radical and then simplify the fractions. Now that we have our x-intercepts, we will move on to finding the vertex and then the range. Knowing the x-intercepts, we can find their average value. This ends up being 6. That is the horizontal component of the vertex. By plugging that back into our function, we can find the vertical component of our vertex, which is negative 5. Because this parabola opens up, our range is from negative 5 to infinity. We will plot the points that we now know and then proceed to connect all of them with a smooth, continuous parabola. Thus, we have, as you see before you, the graph of our parabola.